Welcome back. This is the third lesson recording for IM2, January 11th, 2021. So let's sum up some of the key points from difference of squares from Desmos exercise. If you have 16x squared minus 9, okay, this is a difference of square. What are the patterns that we're looking for? Only two terms. You cannot have three terms. Only two terms with difference of square, and the difference or subtraction of x squared term and the constant. There has to be a negative in between the first and the last, or first and the second term. Okay, so there has to be a subtraction. It cannot be an addition. The numbers are perfect squared. 16x squared is a perfect squared. 9 is a perfect square. Okay, don't worry about the negative sign, but just look at the numbers, and 9 is a perfect square. So 16 is 4 squared and 9 is 3 squared. Okay, so in this case, difference of square, it is in the ax squared plus bx plus c form. This is a quadratic, but b just happens to be 0. Okay, so this is still a quadratic. Now let's see if we can factor the difference of square. For both perfect square numbers, decide the square root. Okay, so 16 and 9. What is the square root of 16 is 4. Square root of 9 is 4. Then use the factors template. Note the negative and the positive. One's going to be negative, one's going to be positive. Something x here. So this is going to be the template for quadratics with the difference of square. Um, and so it's something x and something x. And then therefore you get the 4 to replace the first question mark and 3 to replace the second question mark. Okay, so 4x here, and then minus 3 and plus 3. So one's going to be positive, one's going to be negative. So therefore this factors to 4x minus 3, 4x plus 3. All right, so let's see if we can factor this, okay? Both perfect square numbers, decide the square root, said they're 25x squared and minus 4, they're both perfect squares, and we do have a subtraction, okay? And then use the factors template. The first term square root of 25 is 5, so it's going to be 5x here. And then the second number is going to be square root of 4, which is 2 and 2 here. So it is going to be 5x minus 2 and 5x plus 2. So therefore, the solution is 5x minus 2, 5x plus 2. Again, you can always use FOIL to multiply this really quickly and make sure that you do get the same answer. Okay, but obviously, noticing the pattern is going to be far easier and quicker than trying to factor it using grouping method or area method. Okay, but if you were to do that, since the middle term is missing, okay, you need to set b is to be 0. Okay, if you are ever trying to factor this when one of the term is missing or the middle term is missing, you need to set the x term to be 0x. So at this point, you are going to be working on card number 17 to 19 of Desmos. Please pause the video and try them yourself. So again, the template for difference of square, I mean, first of all, you've decided that, yeah, this is going to be difference of square is because there is a coefficient of 1 here. 1x squared, 1 is a perfect square, 49 is a perfect square, and we have a negative sign here. That means the template is going to look like this. Something x, something x. Okay, and you get the first number that belongs here by square rooting the coefficient of x squared. What is square root of 1? That's just 1. So I don't even have to write that. Okay, so that's not a minus sign, that's just a space order. And then for the last two numbers of the binomial, square root of 49 is 7. And 7, one's going to be positive, one's going to be negative. So it's x plus 7, x minus 7. Card number 18, 36x squared. What is square root of 36? Square root of 36 is 6. Square root of 9 is 3. So the template is going to be something x plus something x minus. So, and the first number is going to be 6x and 6x. So it's going to be 6x here. And the last number is going to be 3 and 3. So 6x plus 3, 6x minus 3. And if I multiply this out using FOIL, I am going to get the original 36x squared minus 9. Okay, card number 19. Our friend Maya factored 9x squared plus 25 to be 3x minus 5, 3x plus 5. Do you agree or disagree? Well, is this a perfect square? I have 9, which is a perfect square. 25 is a perfect square. But what is wrong with this? We have a plus sign right here, okay? And we don't want plus sign. This has to be a negative sign. Otherwise, it does not work out. For example, if I was to multiply this out using FOIL, first with FOIL, first is going to get me 9x squared. Outside, 3x plus times 5 is going to be 3x times 5 is 15x. And then inside, these two numbers, negative 5 times 3x is going to be negative 15x. And then last with last, negative 5 times positive 5 is going to be negative 25. And you think, oh, well, 15x and minus 15x, that canceled out. But notice that this is 9x squared minus 25. It is not 9x squared plus 25. That plus or minus sign, it makes a huge difference. Okay, so this does not factor to 3x minus 5, 3x plus 5. So remember, difference of square, not only does the first term have to be perfect square and the last term have to be perfect square, it has to be a difference of the two perfect squares. Okay, now we're going to tackle some miscellaneous topics of factoring quadratics. So what is the difference between standard form versus factored form? It's just different way to represent the same quadratic expression. Standard form is always written in ax squared plus bx plus c, where a, b, and c are constants and a is not equal to 0. So that means we have to have x squared, remember? So that means these are all examples of quadratics in standard form. Factored form is when it's written as something multiplied by something with no additional addition or subtraction outside those two parentheses, where p, q, r, s are constants. Okay, that does not mean that they have to be integers. Okay, it does not mean they have to be integers, but p cannot be 0 and q cannot be 0. Okay, so that means that's the only restriction is that, remember, to be quadratic you have to have some x squared as the highest leading term. So that is the reason that p cannot be 0 and q cannot be 0. So these are all examples of factored form. You're multiplying, one factor is 3x minus 3 and the second factor is 2x plus 4. What about this? We only have one parenthesis. However, that still is okay. The first factor is negative 5x, and the second factor is x minus 4. In this case, you have three factors. 2x is a factor, x plus 5, 3x minus 1. But in this case, this is not quadratic anymore, is it? Okay, it's cubic because we have x times x times x, so we are going to have x to the power of 3. But nonetheless, this is still a factored form of a cubic polynomial. X minus 3, this is also a factored form because this is just a shorthand way of writing x minus 3 all times x minus 3. So there could be intermediate forms that are neither standard form or non-factored form. And we've used this, okay? So when you were using grouping method, we split the middle term, the x term, into 5x plus 2x, right? And so this is not a standard form because you have two x terms here, right? So this would be not be standard form, and this is certainly not factored form. This might look like a factored form because you have two parentheses, but for it to be a factor, it has to be multiplication between the two parentheses. So notice that this, because of the plus, this is just this is not a factored form. Okay, so do not get that confused, please. Okay, lastly, okay, factorable versus not factorable. So far, we've given you problems, quadratic problems that are all factorable. You've never encountered any problems, quadratic problems that are not factorable. So that might make you think that all quadratic expressions are factorable. It is not true. Okay? The teachers have been choosing all the factorable quadratic expressions. That is the reason that you've been being able to factor them. However, I'm going to be more expression in fact, yeah, far more quadratic expressions are going to be not factorable. However, you do need to learn this factor because this is going to be really quick, and this is a skill that you are going to need for later things when we're solving quadratic equations. To be able to factor is going to be essential. Okay, if you're not able to factor, then you are going to be in trouble there. So that is the reason I am stressing that you learn this now. For example, x squared plus 5x plus 4 is factorable because I can find factors to be x plus 4 and x plus 1. Okay, what I am saying is x squared plus 5x plus 4 is x plus 4 multiplied by x plus 1. And if I use FOIL, I am going to get this. X squared plus 2x plus 5 in this case is not factorable because there are no two integers that multiply to 5 to add 2. Remember, the last number are the two. I'm looking for two numbers that multiply to 5 and add to 2. So 1 times 5 will be a factor, and 1 times 5 do not add to 2. So there are no factors. So to decide if an expression is factorable or not, you actually have to actually do the work. There is no other way at this point for you to know, for you to be able to decide whether the quadratic expression is factorable or not. So you need to do the work. There are no shortcuts. Okay, and what do we mean when things are fact or quadratics are factored completely or polynomials are factored completely? After applying any factoring method, can I still factor the resulting factors? That's the question you should be asking always. Say, for example, in this case, 36x squared minus 4. The first thing you should have noticed is that 4 is a GCF to both terms. Okay, but just say that you did not notice that. Okay, and you just factored it as it is as a difference of two squares, difference of squares, then 6x minus 2 and 6x plus 2. Now you should be asking yourself, is 6x minus 2, is there a GCF I can take out? What about 6x plus 2? Yes, they both have GCF of 2 each. Okay, so this is not factored properly or completely. You need to factor out 2 for the first factor and 2 from the second factor, and now it becomes 4, 3x minus 1 multiplied by 3x plus 1. So now at this point, the final answer is factored completely because there are no other factors to take out. Okay, so at this point, you are going to be working on card number 20 to 26. And then finally, you are going to whatever cards that you did not finish as during the class, you are going to have to finish that on your own because it's going to be class graded as classwork. And make sure that you do have the table of content notebook updated with the skills that we've been covering today and the previously. And I am not going to go over the last Desmos activities just because they are straightforward, and it also goes through the answer self-check as well, so it gives you the answers at the end, so you should be able to get accurate feedback as whether you're doing things correctly, as well as I would like you to fill in the how do you feel, a quick reflection on how do you feel about factoring. Okay, that's it for today. Thank you for listening.